The Intuitive Machines IM-1 mission is sending commercial and NASA payloads to the lunar South Pole region on an uncrewed robotic Nova C-class lunar lander called Odysseus.
The lander is the tip of the iceberg, and what's below that is the full program that is on a miniature scale, very similar to what the Apollo program had.
The IM-1 flight path mirrors the historical achievements of Apollo 2, starting with separation for the launch vehicle on a direct shot at the moon.
That trajectory is basically like throwing a fastball that is going to hit the moon 6 or 7 days later, like an outfielder stretching out to grab it.
The first 4 days are dedicated to flight controllers in Houston firing the lander's 3D printed liquid methane and liquid oxygen engine to make small course adjustments to hit its orbit target around the moon. This particular coordinate system is called the B-plane.
You can think about the B-plane kind of like the backboard of a basketball goal. And you basically know when you shoot hoops that if you can get the basketball in the square on that backboard, it's going to go in. And the B-plane for astrodynamicists is very much the same thing.
With the B-plane on target, Odysseus is prepped for a critical autonomous maneuver on the moon's far side. This critical burn maneuver is completed in the blind, with the moon blocking direct communications back to Nova Control in Houston.
Once we get around the moon, we have on the day side of the moon, the sun heating us from one side and reflected infrared light off the bright moon warming us on the other. Then we plunge into night, and now we're cold on both sides. It's very tough.
About an hour before landing, flight controllers command Descent Orbit Insertion, or DOI. This is a main engine firing to slow the spacecraft so its altitude drops from 100 kilometers to about 10 kilometers above the lunar surface. After DOI, Odysseus coasts for about an hour before starting its final approach.
And then we reach a point called powered descent initiation. The guidance system on board makes the decision to activate the main engine at very close to full power.
Cameras and lasers are feeding information to the lander's navigation algorithms, which provide guidance, navigation, and control. With a safe site identified, Odysseus enters a 3 meter per second descent, then down to 1 meter per second for the last 10 meters to the lunar surface. Now, the lander is using an inertial measurement unit, which is similar to a human inner ear that senses rotation and acceleration. Flight controllers expect about a 15-second delay before confirming the ultimate milestone, softly landing on the surface of the moon.
And I can tell you just from doing our simulations, that's the longest 15 seconds you'll ever experience as you wait for the final light to turn green to indicate that you've landed on the moon.